Hello, and welcome to another 3D printing news Unpeeled with Joris. Today we're going to be discussing a number of news items from some very different areas, I think. One of these things concerns 3D printed construction. The other one is 3D printed facade elements. The other one is 3D printed food. So it's a bit all over the place. And again, the aim of this is a 3D printed news roundup of the top news of the day. So we have five stories for you today. And the number one is Strata making sustainable EPS homes. Now, this is notable because most of the 3D printing construction startups out there are either supported by, have investors from, or use materials from large cement firms and concrete firms. And this means that, well, we're going to be maybe making 3D printed digital construction, but we're going to be using the same concrete. And concrete itself is very problematic because it's responsible for a lot of emissions, and it's a very versatile material, and but also probably not an optimal material. There's a company called Strata, and they aim to do things differently. And they say their solution is more sustainable. Now, so first off, I think what we should realize here is that, hey, there's more out there than just concrete. We could be extruding foam, for example. Foam is a very lightweight material, it's very interesting. What Strata wants to do is make a sustainable houses out of EPS foam. So EPS is expanded polystyrenes made from polystyrene, which is a very damaging material if burnt. End of life, it's problematic, and it's also very problematic if during a production. So for me, it's far from ideal. Would be quite the understatement, I think. But having said that, the fact that they're printing a foam material is much lighter to use, much lighter in construction, and then covering it in a special concrete to kind of get the weatherability in there, that is something that maybe a lot of other companies could be doing as well. And the company itself says it wants to make its houses for 300, 400, 500 years, which would be very different than constructing things with concrete now. And they say they have significant cost savings. So, maybe there's just more out there than just 3D printing concrete. I'm not entirely sure if this is the solution, but it's another path to getting there. There's another bit of news. We have 5 bits of news today. This is the fourth one. That's MeaTech or MeaTech, MEATECH. It's Israeli, very go, very aggressive, very hard, fast-growing bioprinting food startup have signed a memorandum of understanding with Umami Meats. And Umami Meats is a Singapore-based company, and that's notable because Singapore has a regulatory regime that allows you to very quickly um, get approval for 3D printed food. So if you want to get into restaurants and supermarkets, test things out, to have things available in the market, Singapore is probably the fastest place in the world you can do that with 3D printing food. The company also, that both these companies want to focus on seafood. And they want to focus on Japanese eel, red snapper, and yellowfin. Now, for Umami, it's very good to scale up, I think. For MeaTech, it's very good to explore these opportunities and work tightly with the regulatory regime in Singapore. So it seems like a wise move by both parties. News item number 3 is from Laser Centrum Hanover, and Laser Centrum Hanover is working on natural fiber materials for 3D printing. Last week already, we saw a news item from Oak Ridge on similar materials. It's nice to see the 3D Naturdruk project get underway that's doing a similar thing. They're using biopolymers and natural short fiber, also long fiber materials. Now, as you know, if we want to 3D print things for construction, if we want, well, ideally you'd have a build chamber, right? But if you want to make things like 3 by 4 meters, this build chamber is going to be cost prohibitive. So we need to put fibers in these items to, well, strengthen them, but also at the same time keep them from warping and deforming. So we're going to need these fibers. Right now, these are aramids, e-glass type of materials. It's not sustainable. It's very difficult to recycle then the entire composite. So in order to make composites sustainable, you need a bioplastic and then also some kind of natural fiber like flax or whatever is probably the best one embedded inside of it. So this is, I think, a good move. And then that could really open things up for a lot of other players. At the same time, these guys are not looking at 3D printing construction outright or formwork. They're looking at facade elements. So these are the things in modern construction. You usually like you'll print or you'll have a metal structure, put concrete around it, and then you have facade elements on the side to make it look nice. These have a tendency to fall off nowadays, by the way. So making these out of a printed material, making them out of a sustainable material could be very advantageous. The second news item is programmable materials sense their own movements. This is from MIT's SAIL or C-SAIL or anyway, the lab that's really working on inventing some really cool stuff. So what they've done is really ingenious. They've taken a lattice structure and they've put networks of air-filled channels in them, and then they put pressure sensors on these air channels. And these pressure sensors can then sense if this object is under load, is being stressed, or something like that. So we're sensorizing, and the words are there, is we're sensorizing this entire 3D printed part through these air channels, in addition, like with a MEMS sensor or something like that. And that, imagine having a bridge or something with a buckle or a bracket that tests how often it's under load, or that tests if it's under load, right? You can test if somebody's going over the bridge, if you can test how many people are walking on this bridge, for example, if it's being banned, that kind of thing. And imagine how powerful it would be to take all sorts of construction things and all sorts of things, infrastructure things, and be able to know when they fail or be able to know when they're being used. And at the same time, these materials are tunable, which is very nice. But I really like this as a way to say, like, what's the cheapest way we could turn the 3D printed part, even a potentially large part, into a sensor? So to me, that's the really ingenious way that MIT guys did this. Number one is a better gripper design. This is a paper by the University of Washington that it was like a SIGGRAPH project, and it seems silly at first, but it isn't. Um, so what they're doing is they're trying to develop a better gripper, like a gripping arm for a robot arm to pick things up. And what they've done is something that, again, ingenious, and I think that could have a lot more wider applications. What they're doing is they have an algorithm that looks at all the configurations of the gripper, like what kind of gripper, what design of the gripper would it have like 2 arms, teeth, 3, 4, or 5, whatever. And then it looks at the gripping, the kind of the gripper strategy, so how the arm moves and to get it to pick up the object. And it would then design these things concurrently. So at the same time, it looks at the best path and the best shape. Then it 3D prints the best gripper, and that is then used to pick up an object. Now, first off, it sounds kind of silly, like why would I want to do this? But imagine if we did this for nozzles, right? You took a whole bunch of information for a type of nozzle you needed for, let's say, a Mars factory to make Mars bars. And then you just go, based on the information, you go to an optimal nozzle design that's designed in concurrently with the process. So if you want to make the chocolate for a Mars bar every second, then the nozzle would come out a certain shape. Meanwhile, let's say we want to make a Mars factory in Quito in Ecuador, or very, very high altitude, maybe then that nozzle changes. All right, if we want to maybe, we want one point, when we want to speed up our Mars factory, well, we can then change the nozzle design, not only in isolation, but in conjunction with the process that nozzle is going to be used in. So far, very early days for this, but I love this way of thinking and saying, like, and imagine how if we could automate it in an automated way, design optimize things for our world. To me, yeah, that would be huge. That's what the potential of this is really, really huge. So thank you so much for joining me today for the 3D printing news Unpeeled. My name is Joris and I'm part of 3dprint.com. Thank you very much.